area using formulas if you know side lengths and stuff like that, right? Okay. Today we're going to talk about finding area when you use trigonometry. So go back in your memory banks to trig. What was the acronym that we used to use? Close. SOHCAHTOA. All right, so SOHCAHTOA, right? That was our right angle trig stuff, right? Okay. Now, I'm going to give you a new vocabulary word, and this is apothegm. All right? An apothegm is the perpendicular distance from the center of a polygon to one of its sides. So, what does that mean? Let's draw a polygon. Let's see, I got 6 sides there. What's that called?
Hexagon.
Okay, hexagon is 6 sides. Okay. Now, the apothegm is from the center going down, and it makes perpendicular. Okay? It's basically a perpendicular bisector, which is also kind of, if it was going from the vertex, it'd be called what kind of special segment? Altitude. All right, so now my next question for you. What does it mean to be a regular polygon? What'd you say? Yep, all the sides. Regular polygon means all the sides are congruent or the same. Okay? Okay, so just to review up some of our reviews, area is the number of square units because we're only doing 2D formulas. And the area of our triangle is this one. What's this one? Your rectangle or square. What's this one? Trapezoid. What's this one? Rhombus or what else? Okay, beautiful. This one's your parallelogram too. Okay, so what are our trig words? Remember cosine, sine, and tangent, right? All right, so just reviewing the vocab words. Your sine, cosine, and tangents are trigonomic ratios. And we're studying trigonometry and math, right? Trigonomic. Trigonometric. But it's trigonomic. Now you got me all tongue-tied. Well, some people call it trigonometric, but I call it trigonometric. Good? All right. What's my trigonometric ratio from column A to column B when it's opposite leg and hypotenuse? Do we need to refer back?
It's sine.
Okay, because sine is opposite over hypotenuse. So that would go sine. What's adjacent over hypotenuse? And tangents TOA. Good? Remember that part? All right, so let's apply it. Let's find the area. All right, to find the area of a regular polygon, basically, you use the formula of 1/2 AP. All right? Where you need to know the length of A stands for the apothegm, and P is your perimeter. So let's label what we know. This is my center. And I'm going to draw the apothem. I'm going to make the point that it connects R. And then I have radius. We'll make this one D and this one E. Okay. All right, so to find my perimeter, how do you find your perimeter? What is it? What's the directions? How do you find the perimeter of anything?
All the outside length.
Yeah, add up outside lengths. Perfect. Okay, so if this particular side's 4, what are all the sides going to be? 4. So I have 5 sides times my 4 inches, so my perimeter is going to be 20, right? Okay. What is a central angle? What's the definition of the central angle? Remember, it's the angle formed. Oops, helps if I move my hand out of the way. When the vertex is the center. So my center's here. These 2 radius are the sides, and then this part here becomes my center angle. Okay? So if I have a regular polygon and I connect from the center to each of my vertexes, how many central angles do I have? Well, there's 1, 2, 3, 4, 5. So the measure of the central angle is going to be the 360 divided by 5, which gives me 72. Okay. Okay. Now, okay, so now if you think about what we've got here, here's D, here's C, here's E, and we drop that down. If the measure of DCE is 72, then the measure of DCR, this part here, is going to be 1/2 of DCE. So that's going to be 36. Would you agree with that? And if my whole side length is 4, then DR is going to be 1/2 of 4. So DR is going to be 2. So now if I have angle C is 36 degrees, DR is going to be 2. And the whole purpose of why we're doing this is because I want to find the length of my apothem to use in my formula, right? But now that I know an angle measure and I know a side length, I can use my trig to find my other side length. All right, so if you stop to think about what we know, there's my theta, and I know this side. What is that side in comparison to theta? It's my opposite, absolutely. And I'm looking for this side. What is that side in comparison to my theta? Adjacent. So which trig function do I want to use? Tangent, absolutely. Okay, because the tangent of theta is my opposite over adjacent. Everybody with me on that? Awesome. Look at how easy this trig is to you guys now. All right, so plug and chug. If this is the one ratio we're using, which equation can we use to find my apothem length? Well, first of all, is it going to be this one?
It has to be second.
It can't be that one because that has an angle measure of 72, right? So I don't need that one or that one. So which ones am I left with? Is it going to be this one or this one? This one? Do you agree? I don't agree with that.
No, that's adjacent over opposite. It's opposite over adjacent.
There you go. This one's adjacent over opposite. So I want this last one, which is opposite over adjacent. Perfect. All right, so we have a little typo here. So that should be the tangent of 36 is equal to 2 over A. And if I multiply both sides by A, my A's cancel. And I'm left with A times tangent of 36 equals 2. But I want to get A by itself, so I'm going to divide each side by the tangent of 36. And so A is equal to 2 times the tangent of 36, which I can calculate that out into a decimal point at that point. That's fine, you can do that if that makes it. But you can also just go straight to my formula because my area is 1/2 of the apothem. Well, we know that that is 2 times the tangent of 36. And my perimeter was what? Perimeter we already found was 20. So then, now that I have all the information, I can, at this point, just do a plug and chug. So 1/2 times 2 divided by the tangent of 36 times 20. That's my perimeter. Because my formula is the apothem. So here's my 1/2. And then my A was this part. And then my perimeter we had already found to be 20. You with me? All right. Hit enter and I get 27.53. So to the nearest inch, the area of the pentagon is 28 inches squared. Good, better. All right. Okay, problem 2 is basically doing the exact same thing. So I'm just going to go ahead and skip through that. Try and work that through. It's pretty guided. Try and work that through yourselves. But I want to go on to the area of a triangle given SAS. What's SAS stand for? Side angle side. Look at all this back knowledge you have. Your note packet? Okay. All right. So the theorem says that the area of a triangle is half the product of the lengths of two sides and the sine of the included angle. Okay? So here's your, which translates into that formula. So let's look at what we have here. If this is my side B and this is my side C, what is my included angle? My included angle then is A. And so my formula is 1/2 of B times C, the two side lengths, times your sine of A. Okay, are we good?
When will we use that? So that's like, if it's side for side, and then you try to find the angle?
So, well, side angle side is proving that it proves that two triangles are congruent, okay? It basically, what this does is it says that you can use this because we're going to find the area of, we're going to find the area of the two, and it works to find it all together. Okay, it's just a formula they've proven to work. No matter what. Doesn't even have to be a right angle. Okay? Okie dokie. So, what's the area of the triangle? Well, I know my side lengths are 10 and 16. So that means this side and this side are my B and my C. Okay? And it doesn't matter which way you label them. It really doesn't. Okay? That makes this part my included angle, right? Because that's just where the vertex is. So my angle measure is 34. And so now I literally plug and chug. 1/2 times B times C times the sine of your included angle. And so I'm going to have 1/2 times 10 times 16 times the sine of 34. And honestly, plug and chug. So we have 1/2 times 10 times 16 times the sine of 34. And I have an area of 44.74. So to the nearest inch, I have 45 inches squared. Okay? B is the side lengths. You need the two side lengths and the angle in between those two side lengths. And the nice part about these is if you have this information, then you don't have to I would have had to find the height and turned it into a right triangle. I don't have to do that now. I already have that information. It's just another tool. Where'd I get what?
6.
What's 6? 6 over 10.
What's a B?
That's B. 1/2 of B times C times your angle. That was my formula. Okay? Good? All right. Do me a favor. Do these lesson check and success things, reflection real quick, while I hand out some problems for you. And you're going to do your choice, either even or odd. Okay? I am going to collect, so hold on a minute, because those of you who have earbuds in and on your phones and stuff, pull them away for a minute.